Morning.
Good morning.
Good morning, Tata.
Very good morning to all of you. I'm Manjula Vikramatilaka from the PGSS SKE. I hope you all can hear me very well. And so today we are going to have our postgraduate online structure course number 8 on Develop Matlab Apps with Graphical User Interfaces. Right, so our respected speaker today is technologist Dr. Yu Kok Yeo. And we are going to start in another 2-3 minutes time. So before that, I would like to remind all of you some ground rules. As you all know, kindly keep your microphone muted during the whole session, but still you can ask questions in the chat window. And also keep your video turned off until the group photo session at the end of the program. And also remember that there won't be any attendance form at the beginning. So please don't get yourself disturbed. You can just concentrate on the workshop. So there's no attendance form, but at the end of the program, we will share the feedback form. So you have to fill only the feedback form, which will be considered for your attendance as well as the certificate, right? So keep all these things in your mind. And I would like to introduce
Sorry, Manjula, you are muted.
sorry, hope you can hear me. Shall I read it from the beginning or just can continue now?
I think you have to reintroduce. Yeah, from here. Okay. Yeah, from this side.
Right. Sorry. Okay. Sorry for the interruption. So Dr. Yu Kok Yu is a senior lecturer at the School of Electrical Engineering, UTM Johor. And Dr. Yu obtained his bachelor's degree in physics in 2001, and from the University Kebagansan, Malaysia, and his master's degree in 2003 in microwave. And also he obtained his PhD in wave propagation from the Institute for Mathematical Research, University Putra, Malaysia in 2006. And the research interests of Dr. Yu are theory, simulation, and instrumentation of electromagnetic wave propagation at microwave frequencies, focusing on the development of microwave passive devices and sensors for medical and agricultural applications. So, so Dr. Yu himself volunteered to do this program on MATLAB using graphical interfaces. So thank you very much, Dr. Yu, for coming out with this topic and being agreed to do a program with the PGSS SKE. So now the time is up, and I think Doctor is ready to start the presentation, and hope all of you are ready as well. So now I would like to hand over the program, the control to technologist Dr. Yu Kok Yeo, the speaker today. Over to you, Doctor.
Okay, thank you, Doctor. Okay, now I start my presentation. Okay, today I want to share some of the knowledge about how to create the graphical user interface using MATLAB environments. Very simple. the title. Okay, for this presentation, the objective is to introduce the MATLAB-based graphical user interface. Some of you will know what is a MATLAB-based graphical user interface. Okay, because now recently, a lot of engineering systems, they are based on automation now. You can see a lot of apps, a lot of the engineering system, they control using computer. That's why we need the interface. There are a lot of programs to do the interface, like C, like Python, a lot. But those of software maybe is too difficult because maybe although we are engineering students, but we are not in computer base. We are not in computer expertise. That's why we need some software to support us. Simple software to support us. One of the simple software is a MATLAB. Because MATLAB inside they build in a lot of function, engineering simulation function. It's convenient for us to simulate, to calculate some complicated or some complex engineering problems. Here, I just using one example, like microstrip line calculator. In electrical engineering, now all the components normally will be built or fabricated in a circuit block. That's why microstrip line is very important, especially for high frequency. Some of the robotic person, they call it high frequency circuit, is called high speed circuit. The signal now transmit is up to gigahertz. You can see signal now is not in DC like the previous circuit. You can see our mouse, we use the 2.45 gigahertz signal. And our computer, Wi-Fi, or also our smartphone. That's why we need high-speed circuit design. Microstrip line design is the common software to calculate the width and length of the microstrip line on the circuit box. Because we talk about high frequency, the width and length is very important. Okay. And then we found that, and then actually the MATLAB itself got two environments to build the GUI. One is a MATLAB guide, here, MATLAB guide. Another one is a MATLAB apps designer. MATLAB guide actually is an old function in the MATLAB software. This function is available since 1996. Since 1996. And then the new version environment is available since 2016. You can see from there, since 1996, they started to do this kind of GUI development. But now they're using a new environment to make user more convenient to develop its own GUI. Okay. Today we are compare these two environments, but I encourage that if a fresh user, fresh learner, I think better you started with MATLAB Apps Designer. But MATLAB Apps Designer, they not more information about this function, because this function MATLAB guides have history, long history. That's why a lot of information available in internet or some books. Okay, today we are compare these two environments. Okay, you can see from here, the Matlab Apps Designer is a new feature since 2016. Okay. This environment, the new environment, is more easier, user-friendly compared to Matlab Guide. Later we'll see how easier. And also is more flexible. You can see from here, if you're using the new one, Apps Designer, you can package your GUI in a Matlab Apps install file. This one Matlab Apps install file, that means you contribute to the Matlab apps. You can see if you open the Matlab software, on the top of the tab, they got the apps. This kind of apps actually is built by some contributor. Then Matlab will evaluate, is it useful or not? Then he put inside his own software. He put this function is his own software. You can build the Matlab apps install file. And also you can build a standalone desktop apps. That means that you build the GUI. After that, you need to package it. You package as a standalone desktop apps. You can send to anybody, send to your friend to use your apps without install the full version Matlab. You just send the file, maybe only 1 gig maximum. Then people will install your apps. They'll install your apps. That means your friend's laptop or desktop no need have any Matlab software. That's why we call it standalone desktop app. You can package as a standalone desktop apps. But for this environment, guide environment, we just have 2 options only. But for apps designer environment, we have 5 options. We also can package our GUI, become a app, the web apps. That means you can share your apps using the web, using the internet. Okay. Because now it's very simple, very common to use the apps. You can see a lot of open source software because he can build his own open source software, then he can share with other person. That's why you can see now is a lot of open source software. Okay, now we go to see one example. We're using this Matlab-based GUI to create the micro-stripline calculator. Micro-stripline calculator is very common calculator for EE students, especially high study the signal processing or high frequency research like the wireless circuit. Okay. This one is one example online micro-stripline calculator in the internet. You can go to this website to find the calculator. It's a free calculator. Why this is very important? Because for high frequency circuit, this one is very simple micro-stripline on the circuit box. But why it's very important, we need to determine the length and width. Because the width of the micro-stripline will determine the impedance. And also the length of the micro-stripline will determine the phase. Because of the high frequency, that means in 1 cm length, maybe the signal is oscillate or repeat several times because of short range. high frequency. If they repeat along the microstrip line, N and N is repeat around 180, that means we don't have any signal inside this, between these 2 points, because 180 phase shift. Because you can see it started from here and then end from here also 0 signal, because we know that our receiver, our detector will always read the real value. Although we have value, but the value is 180-degree phase shift, then we cannot detect any signal. That's why some of the device is very safe energy. Some of the device, high frequency device, is not so safe energy. The safe energy device, that means they optimize their circuit. Normally, they already optimize. Maybe this kind of circuit normally will create by the very established company, the branded company. They will design very well on their circuit. You can see they will design the length, also the width. The width also important. If the width determine the impedance, that means the circuit inside we connect with different components. Each component got their own impedance. That's why when we connect one component with another component, we need the impedance matching. If we achieve the impedance matching, that means the signal will be transmitted more smooth without any defected signal back to the first component. This also will be optimum the transmit signal, or optimum the use energy. It's very important. If the impedance doesn't match between the component, maybe will be broken the component also. The component, the times use of the component is not wrong. It's not wrong, because always it will deal with the defected signal back to the component. That's why the component is not used longer time. This is very important, especially for high frequency circuit, or we call it high speed circuit. Although it's very simple. Okay, from here, it's very clear. We have 5 input, 2 output. 5 input, 2 output. This dielectric constant actually is the properties for this circuit box, this PCB, because a lot many kind of PCB in the market. We have FR4, we have RT Deloitte, and so on. Some of the PCB is low quality, some of PCB is very high quality. There are different dielectric constant, different material. Although the copper on the material is same, but the material bottom of the copper will be different. This one is the material. That's why we need to put the dielectric constant for the material. We need to know what is the material PCB we use. Normally, we are using the FR4, 4.3. And also the thickness of the PCB. The thickness of a PCB. Common one is 1.6 mm, but some of the FR4 is 0.8 mm. That's why we need to put the thickness also. Then we need what is the use frequency for this circuit. If the use frequency is 2 giga, then we put 2 gigahertz here. And also the impedance. Impedance we want to connect. Maybe one component want to connect with this circuit line. If 50 ohm, then we need to put 50 ohm. Starter point is 50 ohm. Okay, also the length. The maximum transmit power normally is 90 degree because from the 0 up to the maximum 90 degree. Then back to the 0, 180 degree. That's why this length is very important, especially for high frequency circuit. It's possible we send a power here, but the length is 180. Another point there, using the power detector, we will detect 0 watt. Although we have sent the power here, because of the length is 180 degree. That's why the length also very important here. Then we put 5 input parameter, then he will come out 2 output parameter here. One is the width, one is the length. I mentioned again, the width will be determine the impedance of the line. It's very important for impedance matching. The length is very important for the phase. We want to transmit the maximum power because in high frequency signal, although 1 cm, maybe it's only oscillate 2 or 3 times the signal. We don't want the signal from one point to another point oscillate at 180 degree. We want is always 90 degree. That means it will transmit the maximum power from this point to another end of the point. Okay, this one is one example. Here we want to use the MATLAB environment to build a sim like this kind of calculator. Okay. This one is a figure for the microchip line, same like the previous online apps. This one I draw myself using the pen. Okay, then I save as a JPG format. Now I will show the formula, although some of you will not interested this kind of formula because it's not in your field, but I will brief just only explain what formula will be used inside these apps. Okay, this formula actually is obtained from the textbook. Before he put inside the textbook this knowledge, they are do some research to derive this formula about this around this 1970, because around early of 1970 PCB become popular. Before that, PCB is not popular because of the material is not so advanced. The time synthetic material to build the PCB is not so good, and also the coating technology, coating the copper on the material, the technology. That's why before that, normally the people using the wire to transmit the signal, using the waveguide, bigger waveguide to transmit the signal. After that, this kind of PCB technology become popular at the end of the 1960s. That's why around 1970, a lot of formula focus on the PCB, especially the formula how to design the PCB circuit. This one is one of the common formula to design the microchip dimension. You can see, although this one is a width, this one is the thickness of the substrate material. Less than 2 must be using this formula, more than 2 using other formula. You can see, this formula is derived using the conformal mapping. One of the method, electromagnetic method, to derive the formula. You can see inside the formula, although we want to predict the width of the microchip line, we need to know the dielectric properties of the material. can see we need to know the impedance. What value of impedance we need to design. You can see because the width will be determine the impedance. Okay, once we obtain the width, we can predict the length of the microstrip line. We can predict the length of the microstrip line. You can see from the length, it will avoid the frequency here. It means avoid the phase. In the width, you can see without any frequency because it's determine the impedance. The width will be determine the impedance. Now, the length will determine the phase. That's why you can see got frequency here. And then we need to calculate the effective reactive permittivity because the signal is transmitted in the air and also in the material. You can see the signal will transmit in the air and then go into the material. Transmit in the air and then go to the material. That's why we need the effective reactive permittivity. That means this permittivity will be contributed by the material itself, also the air. That's why we have an effective reactive permittivity. Because the signal is transmitted in the air and also the material in two mediums. That's why we need contribute by the air and also the material itself to calculate the length. Okay, I just show some formula only, very brief. You can see from MATLAB code. First, we go to see the MATLAB code first. Actually, it's just only initial to show you what is the MATLAB code later we will use. Because here they got condition, is it? They got condition. That's why in MATLAB code we also got condition if here, else if here. But what is the problem is that the output is the width, is it? But the condition also is the width. Involve the width inside the condition. That's why it's very difficult. We put the width here. We cannot put the width here directly like this kind of formula. That's why we need to do some modification. Because the output of the width also is a condition of the calculation. That's why we do some modification. We have the impedance formula. Then we put this parameter as a tool. Then we can calculate the effective W per H. This ratio as a 2 we put here. 2. Impedance also we put here. 2. Then we can calculate the impedance only at ratio WH equal to 2. Okay, like this point. Ratio WH is 2, this point. And then later will be input the impedance, is it? The design input impedance, is it? If the higher than 2, the ratio is higher than 2, we can see always the value will be less. You can see always the value will be less for different permittivity or different material. You can see always will less. You can see always go down. That's why this point, this impedance minus any point for the ratio up to 2 will always more than 0. You can see this point minus any point up to ratio 2 will be more than 0. This condition implicitly will be like a ratio more than 0 here. You can see this one condition will be implicitly represent the ratio more than 0, more than 2. You can see this point. If any value more than ratio more than 2 will be less than this point. You can see, or because it's go down. That's why we know this trend. Then we can assume like this way. If the impedance, calculation impedance here for the ratio 2, and then this one is our input impedance minus the calculation impedance at ratio 2 more than 0 using this formula. If other condition using another formula. Just only explain what is the formula used in the GUI. Okay, this one is a complete formula. If you put this formula in the MATLAB, you can calculate the L and W. But now we want to put into the GUI. That means not only calculate, but we have an automation function, have an interface. You can see first we calculate the W. Then after that we get the W, the width of the microstrip line. Now we calculate the length. Because now we already have the W value. Then we can write the condition like this. Then we calculate the length. Okay, now we already know what kind of formula we are used. Now we go to the getting start using the MATLAB guide and apps designer. These two environments we will compare. Okay, you can see these two environments. We open the MATLAB, it will come out this kind of window. If you tap the guide here, you will go to the guide environment. That means you build your GUI using guide environment. If you tap Apps Designer here and then press Enter, you will go to another environment, a new environment. You open the MATLAB the same, but you tapping here different. This one and this one will different. Okay, when you enter this, also the or enter this, you show like this kind of screen pop out this screen. If you enter for the apps designer, will pop out this screen. Then normally we'll be using the brand GUI because we want to create our own GUI. We also have some example GUI. That means it's template already available. We just use their available template. But normally we want to create our own because we have our own parameter. How many input and output is determine ourselves. For other one, we also can use the MATLAB template, but the input output is fixed. Maybe you can add yourself. Also same, normally we'll use a brand apps. We also can use some template here. You can see for this template, we have a 3 input, got 1 graph. Maybe some of them is same like this. You can just using this template. This one is input, this one also input, this one also input, but this one is a slider input, and he will give you the bigger output. Okay. After that, you choose the brand GUI default one. Will give you this platform. Another one, he will give you this platform. You can see totally different environment. totally different environment. Here we have certain component. You can dash the component into this template, this platform. You can do your own GUI. How many input you want to put, you can dash the component in. For guide, only few components you can choose. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 13, 14. Only 14 element only. But for the apps designer, a lot. I think more than 30. More function. That's why I encourage, if a new learner, better started from the apps designer rather than using this guide. This guide is okay. Maybe for the old people, they're already familiar with this environment. Maybe they can use this environment. Okay. And now we are focused, go to the MATLAB guide. We are focused this guide first, because this guide process is more complicated compared to the apps designer. The app designer is very easy. 2 or 3 steps you can complete the GUI. But for this guide, it's very complicated. That's why the explanation, more explanation is based on the guide first. Okay. This one only guide. As mentioned earlier, here is a function component. This one is a button component, edit text. And then as know that we need 5 input, is it 2 output. 5 input, output is a W and L. Then we need to choose 5 edit text to input the value. We use the edit text. Then edit text is here. Then the output is a static text. Output is a static text. Then we extra another button here. This button actually is a run button. If you will press the run button, it will show you the answer. We add another run button here, push button. This push button actually is the symbol label like OK here. Okay. Then you can see we dash 5 edit text component. 1, another 2, 3, 4, 5. And then the text 1, 2. And then the push button 1 here. Now the platform have 8 components. Have the basic 8 components. We already have 8 components. We need to rename this kind of component. You can see edit text, all is same name. Now we want to differentiate the name. Maybe this one is only focused on the impedance, the input. Another one is focused on the frequency and so on. This static is output of the beat. This one is the output of the length. This kind of labeling. We need to do the definition for each component here. Okay, now we go to see how to edit the name. We just double click on this element. Click on this element. Then it will show that this kind of figure will pop up. We just double click. If you have a later, we will do some simple try. We double click this element, will come out this kind of figure. Okay. You can see a lot of parameter you can set. You can set the font size, you can set the font name, and also the color. A lot of function you can set. But normally we are setting these two function only, the basic one. Now we want to make the GUI become function, start function only. Other one is to make the GUI nice. The one maybe you can observe yourself, you can try yourself. But the important thing is these two functions. Now the default one you always say is static text, is it? Static text. That's why you can see default static text. You can see here is you will label static here, static text. I didn't put it longer. If you put it longer, you will come out the text also. And also the tab is a text. It's a very common name. We need to name it or rename the tab and also the string. Okay. Here we edit the string become 0. We edit the tab become answer W. You also can put it simple, W also can. You can put it any name. You can put it output W, W also can. Here I put it 0. Another static text, we have two static text, is it? This one is another static text. We double click on, it will come out this figure. Then we edit this string and tag. We edit it becomes 0 first, and then we rename answer L. Okay. We also can put L, output L, or output also can. Output 1, output 2 also can. This one based on what you want to put the name. But you must remember, when you want to edit the MATLAB code, you need to know the name. You need to remember the name, what previously you put in. Okay, you can see the static text becomes 0, 0, because you put here 0. The name become answer L, one is answer W. We already edit the static text. Now we're going to edit the edit text. Edit text also need a name. Particular for frequency, particular for impedance, particular for dielectric constant, also angle and else. Okay. Then we double click the edit text. Double click. You will pop up this kind of figure. Is actually very big. Now we focus on these two functions only. Same thing. We change the edit text become 0. We also change the tab become input ER. We can put any name, but you need to remember this name what you put, because later we will write a program. You need to use back this name. Okay. Here I put input ER. We have 5 in the edit text, is it? You can see we have 5. Another second one, we put 0 input H. The third one, we put the string becomes 0 input F frequency. This one input thickness of substrate, and so on. Input impedance, input data. Later we'll see, you can see 5 edit text, 2 static text, all 0. Now we save this, we click here, run, save this figure, save this platform as a micro sweep line calculator. This one also very important. Later we want to program is very important. That's why every name you put, you must remember, because the name will be used later in your programming. Okay. This one, I think at this stage, we change to see another environment. Okay. For this environment, apps designer is very simple. Here got a lot of component similar like the guide. We just take out the edit field here. But edit field here, we need to choose the numerally because we are put a number. Because you can see edit field got two. One is a text, one is a numerally. If you want to put a number, we just take the numerally one. It's just dash the file input. You can see from here, the output also using the same edit field. They are different compared to the apps designer and also the guide. The guide, the output just now I show is the static text, is it different? But for apps designer, using the same component, output also using the same component. You no need to differentiate what is the output and input. You always using the field, edit field, numbering. It's okay. You can see now, got 5 input, 2 output using the same component. Because we want figure here to show the microstrip line figure, is it? To show the microstrip line picture, then we can dash another image here. Take this image, dash inside here. You will have this image here. Why in the guide I didn't show the image? Because the process is quite complicated. Later we will discuss how to put the image inside the guide. Inside the guide. Okay. But for this app designer is easy. That's why I already dash the image inside here. You can see from here, we dash 7 component, edit field, numbering. Here also got 7 name here. Here got also 7 name here. You can see how many component here got how many name on this component browser. You can see edit field here. You can apps edit field here. 2, he have 2. You can see beside 7 edit field, we have another 2 components. Is it button and image? You can see button also got name here. Image also got another name here. That's why we no need to edit. We no need to double click, just like just now I mentioned, double click here, then go to edit the string and tag. Here he already show you the name. Very easy for this app designer. Okay, you can change the name. You can change the name. You can double click, then you can edit the name here, the label here. You can edit the label by double click this statement. When you edit the text, you can see the name in the component browser also will be changed. If you put H, you can see you will automatically got H here. Just now is the like don't have anything, is it? If you edit the name here, you can see the name here will change. You will, one example, if you put F, you can see F here. You must remember all the name here because all the name will be used inside to edit the MATLAB code. This parameter will use to write the MATLAB code. Like the previous, you can see previous here, you need to remember this kind of name for the guide because this kind of name you need to use later in the MATLAB code. For here also same, for the apps designer, it's more easy, also same. You can see the name all here will be used inside the MATLAB programming. Because I didn't change the button name, I didn't change the image name, that's why he's still using the same app button app image. Other one, you can see the name already changed. FZO edit view. You must remember this kind of name. Okay, you can see you change here. The name will be changed. Okay, automatic. You no need go to edit like a guide. As you change here, automatic will change at this component browser here. Okay. Now we are define all the parameter, all the component in the guide and also in the app designer. Now we want to edit the MATLAB code because we want to do some calculation. We need to put a formula into the GUI. Now we go to see how to edit the MATLAB code. Okay, once you save this file, I go back to the slide. Once you save this file as a microscript calculator, you click OK. Once you click OK, this figure will be automatic pop up. It will automatically open for you. Show the program inside the GUI. This one is for guide. Once you save the file, then you will automatically open this figure for you. But for apps designer, it's very easy. You can see design view. This one is your design view. Another view is a code view. When you change the design view to the code view, click on the code view, you go to the code here. You no need to do save then count then automatic open. It's very quite messy. You just can change anytime yourself. You want design view, you click here design view. You want the code view to view the MATLAB code, you just click the code view here. Then you go to the MATLAB code. You can see quite different between the guide and also app designer. Quite different. Quite different. You can see the environment. Okay. But never mind. Maybe for a fresh learner, maybe we're very scared about this code. Because at the beginning, I start to learn this GUI, I also very scared about the code because it's very important to put the MATLAB calculation program at the right line. If you put in other line, they will give you different answer or give you error. That's why you need to put in the right line, in the right bottom line. Here I will show you very simple example. Normally we will put the MATLAB code below the button function. Below the button function. Always think about the button, the press button. Okay. Now we are open the MATLAB program here. Want to start to edit the MATLAB program. Okay. we scroll down for the guide. Let's say we focus for the guide. We scroll down, go to the function push button callback line. Then we enter to make it one spacing here to put all the program below this function push button callback here. Actually, the upper got a lot. Upper here got a lot of program code like here. We scroll down using this one. Scroll down to find the push button callback. Other callback we ignore it. Other function we just ignore it. We just want to go to the push button callback. Must remember button and got callback here. Then we start to put the calculation below this line. This all is inactive statement. We can ignore. Okay. For the design, apps designer, we need to choose the button because just now got a lot of name, is it? We got 7 edit, view, and 1 image, 1 button, is it? We go to choose the button one. Go to choose the button, we click the button, then he will come out this statement, this icon. Then we go to this icon to choose the callback, it will come out this small icon, add button, push function, callback. We click on this function, we click on this statement, add button, push function, callback. It will automatically go to this push button function, and then it will automatically have a cursor here for you to put any MATLAB command, any MATLAB code here. It's very easy. This one you need to choose. You need to scroll down, choose one by one the line until find the push button here. Okay, for this one, he will automatically find for you, but you need to go to the Apps button, click here, he will automatically come out this icon. We choose callback, click here, it will come out this small icon. Then we click on the add button, push function callback. You automatically go to this line. You automatically will go to this line, and then he will have a cursor as this line. Or you no need to find yourself. And then this for the guide, this space, what we want to put, we want to put the input value. We want to put the calculate formula. We want to instruct the output W and L. This one we want to put 5 input value, is it? And then this 5 input value put inside will be insert inside the formula to calculate the W and L. Here to show the W and L. Only 3 components. Here also same. We want to put 5 input and also the calculation and also 2 output. Same thing. Then we're going to compare the MATLAB code to put inside this space. We go to see the MATLAB code. Same thing. You can see button push callback, is it? You can see but the function, the name, the command here will be different. You can see command different. Never mind. We just always focus on button. Okay. You can see this is the MATLAB code. MATLAB code. We want to insert in this space. This one is the MATLAB code. We want to insert in this space. Button. Focus on button. Because why we focus on button? Because this button is a key. We press the button, he will calculate all the parameters for you. That's why we always focus on this button line, below button line. This one is a simple way to start how to learn the GUI. Okay. You can see from here, started from calculate the W and L is same. You can see started from here. The all programming is same for both. It's same for both. Actually, it's same. Doesn't have any different. Like previous I showed in the slide, this MATLAB code is same for both environment. But what is the difference is the input. How to instruct the GUI to inform the GUI, this one is the input value. For guide, it's quite complicated. You can see you need to write some code for this name, this ER, this value you want to put in the calculation. You put the value in the edit box here. This one, still remember, this name you must remember because you put this name in the tab, is it? That's why you need to tap this function. str2 number, that means you need to know this one is a number, digit, it's an integer number, it's a digit, it's a number, it's not a text, not a word. Your input is a number. Then handle this number in string format. Also same for H, this value want to put inside the formula to calculate. But in the input box, you already name the input box as the input H. That's why you need to remember the name here. Input Z, input theta. This name you need to remember because previous you edit in the tab using this name. Okay. Okay. With this name you need to remember. This one you can copy from the example, then you change this name. It's okay. Output also same. You can see output, just now you name the output as an answer W, is it? Name the output as an answer L, you need to put here the name. This one to set the output, to show you the output. At this component, it will show you output. Because you calculate the W and H and L, here is the number of W, the calculated W and calculated L. Because in meter, we want to change the output as a millimeter, we multiply with 1000 here. Because all calculation in meter in standard SI unit. In SI unit, that's why although in meter, we need to change this in millimeter when we want to show in millimeter. This one to show how many decimal, the output decimal here, 2 decimal. This one is your component. You need to remember the component name here. It's very simple. Just only need to edit the input and output. Need to remember the command for the input and output. Or you just go to the internet to find this command. And then copy, change your name only, this name here. That's why you need to remember what kind of name you put in for each component. Okay. This one is okay. Now we go to see about the App Designer. App Designer is very simple. Just now from this component browser, you can see here only have a name, is it? But the name you need to add only dot value. This one is your name. Remember, in the component browser, then you copy this name from the component browser, put here, and then write another dot value here. Add another dot value here. Do another dot value here. You just only need to put dot value here. Very simple. Compared to write a lot of command. Handle str2 number, string to number. Actually, this command is meaning is string convert to numbering. That's why you say str2 number. Actually, the meaning is string format convert to numbering. But here you no need. You just add dot value. All dot value is, you can see, although it's output here, output here, W, is it here? Output also same. You just output dot W. This one is the output value, calculate output value, calculate output length. You just add dot W, a dot value. You no need to write another command like set, handle, spring, and so on. This kind of command is very simple. All dot value is okay. It's very simple. For this main MATLAB function is same. Both is same. Don't have any different. Just only the input and output command. For app designer, simple. Just add dot value. All the name behind add dot value. Output also same. Okay. Now we go to see how to insert the image to GUI. Just now, why I didn't show to insert the image in guide? Because the process is quite different compared to the app designer. That's why at this stage, I just show you how to insert the image. Okay. Let's say we have an image just now. We draw the image using the pane, and then we save using the JPG format. We have one figure here, saved using JPG format. For apps designer, very simple. Just now in the platform, we already have an image inside the platform, is it? We just click on the center of the image. They will come out the browse here. It will come out one of the black box writing the browse here. You need to go to the center and then you click on the browse here. It will come out an icon. Say what kind of file you want to open. Then you go to choose this figure file, click OK. Once you click OK, the image will automatically go into this icon, image icon component here, become like this. Very simple. You insert the image very simple. No need to do any programming. No need to do any code. You just flash the image component here and then go to the center. It will come out this box. You click on this box. It will come out the icon to ask you what kind of file you want to open. Then you choose the figure file, click open. The figure will automatically go into the image box like this. Now we go to the guide. Guide is quite complicated a little bit. For the apps designer, we want to put the image, we use the image component. But for the guide, we want to put the image using access. We plot the graph also using the access. We put the image also using access component. Graph also access. Insert the image also access. But apps designer, graph different with the image. Okay, we dash the access into the platform. Let's say this platform. There's any space here. We dash the image here. We dash the access here. Dash one. We will go to inside the platform. Any space here. Can arrange your space here. Okay. Then you have an access component in your platform. Then you need to edit the platform. You double click this component. You'll go to the edit properties inspector edit. Then you go to see the tab. The default tab, he will show you the name as access1. Access1. Okay, you remember this access1. You can change your name. You can change any name by using the default. Then you need to go back to the window, the program screen. Go to find the function line here. Microstrip calculation opening function, this line. Other line cannot function. You need to go to this line. This one is your file name, microstrip line calculator. Then you need the keyword is the opening FCN here. You need to find the opening FCN. At the bottom of the opening FCN here, you need to write the command. That command, only 2 lines. Access, this one. And then handle, this one. And then image show, this microstrip line. Because you save this figure as a microstrip line figure. The name as a microstrip line, this figure. But this figure format is a JPG. Then you need to write .jpg. If this figure is in ppn, then here you need to write ppn. This one is based on what format you save the figure, the image format. This one is the figure file name. Then you run again. You will insert into the access here. This one insert into the image here. From here is clearly you can see, although a same figure, same resolution figure, we put inside the guide, you can see the figure is not so nice. You can see the line is not so nice. Although we are good resolution figure, but when they put inside here, you can see. However, the same figure file put inside the App Designer image component, you can see still remain a high resolution figure. Still remain the high resolution for the figure. This one using guide environment. This one using App Designer environment. Also, you can see this kind of box you can learn yourself, observe yourself. They got a lot of function you can observe yourself. You can also take out dash some text here to label the unit, label the symbol here. But for apps designer, you no need to extra dash the component because the component itself available the label here. Maybe you need to extra the unit only. Okay, later I will demonstrate, brief demonstrate. Maybe you are more understand. I will demonstrate, brief demonstrate. Okay. Okay. Now we already complete the GUI, is it? We complete our GUI. Now we want to save this GUI or package this GUI in standalone desktop apps or web apps or other format. We want to share with other people using different format. Now it's already complete the GUI. Now we want to make this GUI either is a apps, web apps, or standalone software, or some of the format. Okay, now we go to see how to package the complete GUI. Now we want to package it as a apps or web apps or standalone installer. Okay. For guide, the step is quite complicated. Never mind, I show you here. You need to open back the Matlab window. Then you choose the apps here. This app is the Matlab apps. Maybe some of the interested researcher contribute the apps to the Matlab company. Some of them, they do the apps, they post in the Matlab website. The Matlab company will evaluate the apps. If the app is very useful, they will put inside in his own software. You can see here a lot of apps here, is it? Actually, this kind of apps will contribute by different researchers. Then we go to these apps. Now we want to package our GUI. We need to find the apps. We click on the apps. Then we need to find the apps. Go to the application deployment apps here. Because app got a lot of apps, we take down, find these apps here. Because we want to compile our GUI. And then we click on this application compiler. Click on this. Then you will come out this screen. You'll come out this screen. Okay. Come out this screen. Here you have a lot of box you can fill in. This one you also can insert your figure. Because later you install your apps, it will come out this label. Maybe you can put your company logo or the software logo here, your own software logo. Then when you install, it will come out the logo like your own product. Because now becomes standalone apps. We no need install any Matlab. You can share this file to any person. The person can install it standalone. This is a function here. Then I will teach you, I will demonstrate how to package the standalone apps. Okay, now we put up this one. We focus on this part. Okay, we focus on this part. Okay, we go to this part first. Okay, this part first. Okay, now we click on this plus symbol. Then we choose the just now our save GUI file. You click on, you will see what kind of file you want to open. You see, I want to open the previous GUI, which I already created. Put here. Okay. Now you already insert your GUI file here. Okay. Insert GUI file here. You click here. You're asking you what kind of file you want to package. Then you choose the GUI file. This GUI file you put here. Then you will show you this file already go into the system. Okay. Now we go to another part here to show you want to choose runtime including in package or runtime download from the web. Normally, I will choose a runtime including in the package. Because I share my apps with other friends, the user, the friend, no need to download again the function inside the website. All is in one file. You just install your apps, then we can use. You no need say, I want to install, then some file is missing. You need to find in the web, in the internet. That's why we just directly all file provide to the friend. Because sometimes install, suddenly you don't have internet, how to install the file got problem. But if you choose the runtime include in package, you want to save is quite long. You need to use a long time. That's why I choose this one. But you're using long time to save. When you choosing this one have a file. This file inside here. Sorry, here maybe I copy wrong. Here got file. You're choosing this one. Then you pick this package. It was directly package the file for you. Later I will show you. After that, the package, what is the form of the file. Other one you can fill in yourself, but I didn't fill in. You can put your company logo here. When you open the apps, you will come out the logo first before you go into the GUI. For some of the figure here, you can put any logo. Okay. You choose a file here. You choose a runtime here. You can fill in some information here and click the package here. Then he will package for you. Okay. Just now, just focus on MATLAB guide. Now we go to see how to use the apps designer to package the apps. For apps designer, we have three options: MATLAB apps, web apps, standalone desktop apps. MATLAB apps, they mean you share your apps, upload to the MATLAB website. Maybe you contribute to the MATLAB's company, you create one apps, you upload to the MATLAB website. MATLAB user can try to use your apps. Maybe the MATLAB company found that your apps is very useful. They will adopt your apps into this product. This one is MATLAB apps. Okay. We also can package our GUI become a web apps. That means people go to your website, web app desk, use your calculator, online calculator. You can build your own blog. Maybe you say, I have a one apps very useful. You can free use it, open source. And people will go to your blogs, use your apps to calculate something, to solve some problem. Okay. Then you also can package the GUI in standalone desktop apps. That means you package in one file. Then you share, you can email or share to your friend, your program, your apps. Then your friend just install these apps only. No need to install the whole MATLAB program. No need, your friend no need have a MATLAB program in the laptop or desktop. You just install your apps, then he can use your apps. Okay. For app designer, simple. You can see all is one screen. All function is in one screen. You can see code view, design view, and also the compiler also in one screen. You can see the compiler available on the top of the apps designer platform. When you click on this share, you'll come out 3 options. Just like I mentioned earlier, you can create your MATLAB app, then upload to the MATLAB website, or you can create your blog web apps. That means online calculation. People online can use your program, calculate, or stand alone. That means you create one file, your own software, then you share with other people. Okay. Then you click on the share, you come out 3. You can choose one. And normally we choose the standalone desktop apps. At least you are doing the website company, maybe you need to web apps. Okay, here is a reference. This one only I take the formula from this conference paper. Actually, prosa book, a lot of formula they take from the journal and conference. And also I refer to the MATLAB books. I learned some of them, some of the function in MATLAB books. You can see, you can download from the internet. These 2 books I found from internet. Okay, thank you. Okay. Later I will show you some now I show you some of the example. Okay, I'm going to show you some. Okay, yes.
Okay, sir, continue. It's okay.
Okay. Now I show you some example. I show you some example here. Okay, I show you some example. You can see when you click the, okay, I show you again. When this one GUI is complete, you test the GUI is okay. Now you go to packaging using this one. Okay. You do the package. When you pick the package, this package, they will come out this kind of folder in your desktop. You're asking you the folder in which location you want to locate. I click desktop, it will locate at the desktop. Okay. If you open this package, inside he got 3 files. He got 3 files.
Sorry, Dr. Yu, are you showing another application because we are seeing the slides?
Oh, okay, sorry. Go to there. Okay. Okay. Can you see? Okay.
Yeah. Now seeing your folders.
Sorry. Once you do the, thank you. Once you done the package, you click the package, you locate the package in the desktop. Let's say in the desktop, then you can find one folder exists in your desktop. Then you open this folder. He got 3 folders here inside. Then you can share this folder to your friend. Then your friend will be click on this icon. He will install the software, install your apps. And also you can share tree for them. This one is for testing. Let's say testing. This one is for you to testing. You no need to install. You just click on. You can see I didn't put any figure here. I just using the default. If you want to put any figure, let's say your company symbol, your software symbol, you can put
Doctor,
it.
Doctor, I think you need to share the screen.
Okay. Okay.
Because we only see the folder.
Okay. Okay. Okay.
Yeah, we can see now. Yeah.
I click. I open again. I share. You can see he will try. If you double click this one, I show again. Maybe just now. Okay, I double click again. I double click this one. You will show the symbol here. You can put any symbol like your company logo or your software logo. You will start then pop up this one. You pop up this one. This one, because last time I first study, I just using button to insert the figure because the time I still learning how to insert the figure. I didn't know the program yet, the code yet. How to insert the code yet. This one is example. You can see like this. You click on this. That means you can share this folder to your friend. Your friend no need to install Matlab anymore. You just share this folder to them. He install these apps, then he can use. Or you can share this for them. This one is try. You no need to install. Click on. You always say, are you allowed or not to open this app? Then allow, then open, then complete, close it without any disturb your desktop or laptop. You can see for this one, you can put any value. Let's say FR4, thickness 1.6, frequency like 2.45, impedance 15 ohm, 90 degree. Then you calculate the width and length for you for this line, for this microstrip line. Actually, microstrip line is very common, but for high frequency, you need to be careful about the W and L, especially now, all circuit in high frequency. That's why some of the company, the product is save energy, some giving a same spec, but you need to use more battery because it didn't design well this circuit. Although all components inside same component, all chip is soldered inside the circuit, but they have another important thing is the width and length of the line connect the two components. This one is ideal line. Actually, in the actual circuit, we got a lot of components, thousands of components. That's why the researcher, they will try one line, try and error, change the line, try and error to get the optimum performance in the company. That's why I use a lot of time to design one high performance and optimum circuit box. You can see people, you know that now internet is very common. People can copy the same product. You need to careful about the length. The length will be determine the use of battery, also the performance. Although we're using the same product, same component, width is very important for the line. Or high-speed circuit. This one is one example. You can see if you click the package, it will show you this figure, this folder. Folder inside got 3. For testing, you no need to install. For testing, it just come out. Can you see the okay, like, okay, still like, okay, can you see the
Not yet.
folder? Normally this folder, you install it. Okay. This one is one example using the apps designer. This one I try myself last time. It's very simple. I try myself. It's very simple. Convert the temperature unit. I test, I try it. Okay. Okay, you can see it will come out this figure. This one is default. Doesn't count anything. MATLAB is quite a heavy software. You can see this one is using the apps designer. I open it, then this one last time I try myself. I want to try is it work. This one is in other unit for temperature. Let's say this one 78. Enter 25.56 degrees Celsius. This one I didn't do any unit, just try only. You can see for apps designer, you can change the Celsius. You will change the unit app, and then change the app, you will change the Celsius. Very flexible. Let's say I want 30. What is you can see you will change here. For apps designer, it's very simple. Here I didn't put any button, any push button here. Just enter, you're changing the value. We say 90, enter 32.2. You just need to put the formula for changing these two units. Okay, this one I will show another example, like this one. Another example. This one I haven't packaged yet. I just complete the GUI. I haven't packaged. I just show you how complicated you can do. Matlab is quite heavy. You need to take time. My account to open. Okay. Can you see the program now? You just open the file, you show the program. Okay. When you click run, here I open other one. Okay, never mind. I show another one. Okay, I show this one. This one I'm using App Designer. Okay, can you see? Okay, App Designer. I'm using the App Designer environment to create this GUI, but I haven't packaged yet. Take a long time. Normally it's very fast. Okay, you can see for App Designer platform environment, you can see a lot of function compared to the guide. Guide only 14, very simple. But for App Designer, you can see a lot. And then a lot of function you can try. You can also create a tab. Maybe this tab is to give an instruction, your app's instruction. Another one is to calculate. This one is calculate. Then what is the benefit here? When you click run, what is the benefit here? When you create the web apps, normally your handphone don't have any keypad, is it? Any keypad? Then you just only use touchscreen to adjust the value. Okay, can you view? Can you see the figure? Okay. You can see from here, or maybe this one, the platform size is different. Okay. This one is very easy for the apps designer because it's a lot of button, a lot of nodes. like this kind of node. That's why you can design your apps without keying the value, because some of the apps, they use the smartphone. That's why I put a lot of this kind of node. People can use the touchscreen to adjust the value here, without keying the value. If you want to key in the value, also can. Let's say you want to key in the value, you also can. But when you're using the smartphone, maybe you don't have any keypad because the screen is very small. This function is very useful. This one is rain rate. This one is a cloud liquid water. This GUI is to calculate the attenuation of the signal at gigahertz, at terahertz, because in future there are the 6G. Now it's a 5G generation. 10 years later is 6G generation. The frequency will be shift to the terahertz. Now the operating frequency is around gigahertz. Maybe in the future, because all performance need to improve 100 times. Gigahertz frequency is not sufficient to support this performance. That's why in future 6G, the planning using the terahertz. The terahertz is nearly to the optical frequency, but it's not optical frequency. It's between the microwave frequency and optical frequency. That's why in terahertz, sometimes they got properties of optical, sometimes they got properties of microwave. They got two properties mixed together. This apps is trying to calculate the attenuation signal. This one is above sea level. If the transmitted signal is different sea level, what is the attenuation? This one is a transmit power. We generate how large the power. Here you can see if we refer to free space attenuation. Okay, this one is the distance between the signal and receiver. You can see it will show you the graph. This one, because of the weather, got rainfall, you can see the rain also can absorb the signal. When a raining day, your astro cannot receive very well signal because the water very interested about microwave signal. That's why we come out of microwave oven, because food inside containing water, we provide the microwave, high power microwave. It will absorb by the water and heat up the food. That's why in raining day, we are very difficult to receive the signal, radio signal, TV signal, and other like Wi-Fi signal also same, because the water absorb the signal. Okay, that's why we got raining factor, we got cloud liquid water content factor, and so on. And also based on the antenna, performance of antenna, and the sea level. Because sea level, temperature will different, pressure will different, humidity will different. And also this one is distance between the transmitter and receiver distance. This one is a frequency. This one is the generate from the transmitter, and then this one is the attenuation. This one total alternation, weather, pressure, and so on. This one is a DC power. Using the apps designer, App Designer. App Designer, one benefit is they got a lot of function. You no need to using the keypad. You can design your UI using the node, using the slider. Then people no need to using keypad to key in the value. You can see you change this value. You also change with it. If you want to use keypad, also can. You see, same. Okay. This one using the App Designer environment. Okay. Now we go to see another environment. Okay, we go to see maybe okay. Okay, can you see this one are using the guide environment. This one using guide environment to simulate the antenna. Okay. Okay, and simulate the antenna. Go to another. Okay, you can see this one is another example. To simulate the Yagi Uda antenna. This antenna is very simple. It's very common, especially your house got TV. Normally, they use this kind of antenna for TV. Okay, now we want to design how many elements for this antenna. Let's say we want 5 elements. This TV, let's say 200 megahertz TV. Then the dimension, the radius of the rod, let's say 5 mm. Then we can calculate. We can know the radiation pattern. We can know the antenna gain. We can know how long the antenna we need. We also can know wavelength. We can know each length of the array. We can design the dimension of the array for each array length. Because we just 5 elements, if we just say 10 elements, it will show more, because more. This one is the distance between the array. This one is the length of the array. This one is the radiation pattern. Using the guide environment to create the GUI. Let's say I want to package this GUI. I need to go to the window here, beginning. Click on the apps. Go down here. Find the app function. This one. You can see now a new product. They now add another apps here. Then we click on this app. Okay. This kind of apps normally is built by some researcher. They post his app on the website, Matlab app site. That's why I got Matlab apps. Then the MATLAB company will evaluate the benefit of the apps and put inside his own product. You can see, can choose just now the product, just now the apps, just now is Yagi Uda, put here, okay, now we choose this one, we click the package, then he will come out package. Like just now I show you 3 files. Then you can share your file with other friend. Your friend just install the file, can use it without install the full version of MATLAB. This one you can put any figure. You can open any figure, your company figure, your software figure, or your picture. And then you can fill in any information, any instruction, or any limitation. You can set here. Then when you open the apps, it will show the name, company name. It will show the contact information. It's very simple. This one is guide environment. Okay, guide environment. Okay, now we go to C for okay. Now we go to see about for this environment, this apps designer environment. You can see very simple. You just click on designer, is here. You can choose either one. If you want standalone, click on. It didn't come out yet. Maybe take time. On. Okay. It didn't come out yet. Okay, already come out. Okay. Also the same. Now you already automatic upload the file into this part. Then we choose this one. We click package. Then you can package my GUI in standalone desktop apps. Okay. It's very simple, is it? Maybe people will know, okay, this one is the end of the presentation. How a beginning? Okay, now we go to see the beginning. This one is when we open a MATLAB, it will show this window. Shows this window. If you tap a guide, let's say tap a guide, enter. This one is an assist GUI. Normally is this one. Then we choose the brand. Brand. It will give you this platform. It will give you this platform. Okay. Let's say we want to make the calculation, make 1 + 1 = 2. Then we put this on 1, 2.
I think you are showing the wrong screen.
Okay, can you see? Is it just now? Can you see?
Yeah, now
okay. Okay, I try again. I always demonstrate. Okay, let's say we tap the GUI guide. Okay, it will come out this screen. And we choose the brand one. Choose the brand. It will come out this platform. Let's say we want to create a calculator. 1 + 1 = 2. So take out 2 input and then 1 output. And then we also can label it. We want to label, is it these 2 text is no function because we can edit, double click. Just now we say that we focus on string. And also the tab, is it? Change it and go to close it. Okay, you can see plus. Because this one is no function, just only symbol. That's why we just only go to the string here, equal. Okay, we close it. You can see equal. Okay, now we want to, this one is the output, this two is the input. Then we edit either one. Maybe we edit static text first. We edit string, it's become a 0, started from 0 initial. Then we give him a name, output. Okay, we give him a name as an output. Later we must remember the name. Okay, this one, we give him a name. It started from 0, also same. Give you an initial value is 0. We give you a name as a input 1. Okay. This one give you a name as a input 2. Okay. Now, all the components already defined. Now we want to edit the MATLAB code. Edit the MATLAB code, we go to save. Okay, we save on desktop. Let's see. Calculator, or we just common calculator. Okay, we save at this name. Save. You will automatically come out the program here. You will come out the program here. Okay. Maybe we are forget one thing. We close the program. We forget one thing is a button. I think button is better for initial to study, because all calculation we put below the button, then it's better we press the button, he show the answer. Later, for this kind of calculation, you need to find the line. Maybe first you will confuse what kind of line you need to put the value. Okay, we put the button. The button say run. The name become run. This one, maybe we just put button is enough. Let's say this one calculate. Calculate. Okay. You will give you the calculate, but in the MATLAB code, you need to click the run. You need to remember the name is run. Okay. Now we have this. When we save, it come out this figure, this MATLAB code. Then we go to find the button one. Go to find the button one. You can see run button. Run button here, call back. Run button. Then here you will write the program. A1 equal to number program. program here, show you, because okay, copy this one. Okay, this one, str2 number. Okay, str2 number. How to make it? str2 number get, and you can see, you just follow the command get this one, you can see get handle. Okay, handles dot, just now input 1, just now my name is input 1 thing. Okay, then another input we put this as a A2, write the same thing. We copy. The name just now is input 2, is it? We set the type is input 2. Okay. Now the output, now the answer, let's say answer AN is equal to A1 plus A2. Okay. Now the output here is set as a handle dot, just now my name is output, is it? I put the output here, dot output. Okay. We just follow the program. This one to set the decimal. This one is my answer, AN. This one, AN, answer. And then finish. Okay. Are you finished? You already got 2 input. This one is our program. Add. This one output. This one input. 2 input. Program. Output. Okay. Now we try to run. Try to run. You can see the figure or not? You can
Yes.
see.
Yes.
Okay. Then you put 1 plus 1. What is the problem? Oh, handle. I tapped the wrong code, is it? Oh, handle here. Handle, wrong code. Okay. I run again. Okay, I run again. Okay, I save and run again. Okay, swing. Handle. This is not swing. Later I show. Okay, the string is as print. Go to see my program. ER2 number, get handle. Okay. Okay, this CI without this one. Suddenly got problem. I'm not sure. Okay, go to back to see that answer. Output. Okay. Run. Okay. Output. Okay. Okay. Oh, sorry. I put here wrong. It's correct. That is correct. Mhm. Okay, I need to save again. Close again. Mhm.
Sorry, just some suggestion. Do you need to declare those handles global since you are calling them from a different function, which is the button?
Okay, maybe I need to here because sometimes they will confuse. Sometimes you're wrong, then the MATLAB will started confused. Then you need to close it and open again. This is I scared that open take times. Actually, the program is okay, but sometimes you have a wrong. Then when you collect, you will still got a problem because inside there maybe got back setting or something. Okay, maybe I need to close the callback because now is like I'm using other maybe confused, but actually the process is like this. The process, maybe you want to add, let's say you want to open again. You want to open again your program. You just tap the guide. Then you back to here to see your program, common calculator. Open, you will go back here. Maybe you want to edit again. Edit again some of the labeling. Let's say you want to label. This one is the A1. Okay, you can see label A1. Maybe you want another one, A2. You can do a lot of things. A2. Okay, then you also can make it nice. Like let's say you want to make it all in the one box. You can make it all in one box. In the box here. And you can one by one. You can play around of the function. Because just now I think the program is correct, but because of started wrong, you will got problem. You need to close the whole MATLAB open again. Then you can do a lot of things. You can like banner, you can see calculator. Okay, you can change also the font size, also the name. Like this one, if let's say you want time new moment. Let's say font size you want will it be 12. Okay, you can see it give you new time new moment. This one also can, you can change. Let's say you want this one become 12. This one other time new moment, you can change. Also the color. Let's say you want to change the color. This one you can play around. Okay, color. Okay, sorry. Okay, color. Okay, you can see become different color. And also this one also same, the answer, font size, and color. And also the inside here, you don't want the white color, you need purple color also can put. It's all setting. You double click here, your all setting is here. This one is for guide. This one is for guide. This one is for guide. Maybe you can use other function like this kind of function. You can try. Yes.
Excuse me.
Here I just yes.
Sorry for disturbing. I would like to suggest, if you don't mind, if you do a kind of screen recording of how to do it. Later on, we can send it by email to the participants because of the time restriction.
Okay.
Yeah. Now, I'm just suggesting. I mean, if it is not working at the moment, later on
Okay.
you can do it on your laptop and do a kind of screen recording, just
Okay.
2-3 minutes video. Then we can share it along with the slides.
Okay.
So I think because of the time restriction, I thought so. Okay. You can just conclude. No issue.
Okay. Or maybe I will prepare calculator for the guide environment and also app designer environment. I will send to Dr. Manzura. Manzura, is it? Or I send to
Yeah, I'm
Sim.
Manjula.
I send to Sim. Maybe Sim will help me to manage because and then I will compare the two calculator. It's simple calculator. Is it okay for all joiner coming to this presentation?
Yes, it's okay.
Okay. Maybe the time is already finished. thank you all coming to join us. I'm very happy today to share some simple GUI for everyone. And also I would like to thank to Dr. Mazura to then become a moderator. And also I would like to thank Asim, helped me a lot. I will also finally thanks all the coming join our presentation joiner. Hope this presentation can give some benefit for you all, because it's very important now. Engineering is all automation, because MATLAB also can control Arduino. We have a function can control Raspberry Pi. You can do some simple GUI to control your system. That is my conclusion. Thank you again.
Okay, thank you very much to Dr. Yu Kok Yo for your very valuable presentation. Actually, I wish if we had more time, it would all the participants would like to attend. I mean, if possible, we'll try to arrange another session. Or anyway, you can do some kind of instructional video on how to do a kind of a simple calculation, so that we can share it with the participants. So again, thank you very much for committing your time and volunteering to do this workshop on how to use these graphical user interfaces in MATLAB. So thank you very much, Dr. Yu, and also thank Mr. Sim Manseng, our Secretary of the PGSSKE, for coordinating this program and letting our participants to have some knowledge on this valuable topic. Okay, so while thanking the speaker, and I would like to thank all the participants for being with us for this time and attending this program. And now I would like to remind you to provide the feedback, right? So you can scan the QR code on the screen, or you can click the feedback link. That link is also given in the chat window. So please provide your correct details, your correct matric number, and the correct email address. And many of you are asking in the chat window about the slides and the video. So sure, you will get the slide and the recording, the video recording of the workshop. We can send you, but it will take some time for us to get it from the SPS, but sure, we will send it. But the slide and your e-certificate, everything will be sent shortly. So please provide your correct email address and also your correct name and metric number to be inserted in the e-certificate, and also for marking the attendance. So don't forget to provide the feedback before you leave this room. And now I would like to invite all of you to switch on your video cameras. We are going to take a group photo. Doctor, could you please stop sharing your screen?
Okay. Stop sharing. Okay. How to cancel? Is it already stop sharing? Is it I already stopped sharing my screen?
Wait.
Okay. Is it I already stopped sharing?
Okay. Still we see some screen. Participants, please don't leave until we take the group photo.
Okay, so 3, 2, 1, smile. Okay.
Is it okay, Sim?
Yeah, okay.
Okay, thank you very much. And thank you very much again for all of you for being with us. And if you have not filled the feedback form yet, so please click the feedback form link and at least open the feedback form before you leave the room. Okay, thank you very much and good day to all of you.
Thank you
Bye.
very much.
Okay, thank you.